Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Izzul bin Yaakob. ID number AA18250. So, my research title is the effect of water cement ratio on the fresh and hardened properties of mortar containing cockle shell as partial cement replacement. Okay. So, for the introduction, carbonation is a chemical reaction that sequester carbon dioxide in cement-based material. The most of extensively utilized construction of material are cement-based material. The cement industry is a major source of carbon dioxide. As a result, the cement industry is increasingly focusing on sustainable and low carbon development. Researchers have been studying the use of agro waste ash as the principal element in mortar for years. Rice husk ash, palm oil fuel ash, and cockle shell the example and known as pozzolani ash. To improve mortar strength, reduce cement content, and lower manufacturing costs. The research aimed to investigate the effect of water-cement ratio on the fresh and hardened properties of mortar containing cockle shell ash as a partial cement replacement. The study aimed summarized as follows to attain the desired outcome. Problem statement. First, reduce the waste. According to the Malaysian Department of Fisheries, 57,000 tons of cockle were gathered along Peninsula Malaysia west coast. Furthermore, cockle shell may emit an unpleasant odor if left untreated and discarded carelessly. Because of its high usage as a food ingredient, cockle production climbed by 33% in 2010 compared to 2009. The shell, on the other hand, are dumped and left untreated, causing environmental problem and a foul odor. Secondly, reduce the carbon dioxide emission. Carbon dioxide emission, one of the cement industry by-product, show the influence of cement on the environment. The cement industry is one of the greatest carbon dioxide emitters. Global carbon dioxide emission from cement manufacturing account for 4.5% of global carbon dioxide emission, with 50% coming from the chemical process and 40% from fuel combustion. The amount of carbon dioxide emitted during cement manufacture and the process of cement hydration is roughly 900 kg for every 1000 kg cement production. Carbon dioxide is a significant contribution to global warming and ozone depletion. Research objective is to determine the effect of water-cement ratio on workability of mortar containing cockle shell. Secondly is to determine the effect of water-cement ratio on compressive strength of mortar containing cockle shell. And third one is to determine the effect of water-cement ratio on water absorption of mortar containing cockle shell. Significant research. First is to reduce the cost of raw material in mortar production. Secondly is to make better use of the waste material generated and to limit the amount of waste. And the third, to develop environmentally friendly, long-lasting concrete in the construction industry. Okay, this is a literature review on cement, sand, and cockle shell. Okay, for chemical content of cockle shell, comparison with OPC. Okay, next is particle size distribution of cockle shell, and this is gap of knowledge. First, most of the previous research recommend that the optimum replacement level of cement by cockle shell are 20 to 10% respectively. Second is cockle shell contain 96 calcium carbonate that can be converted into calcium oxide, which can absorb carbon dioxide in the production of concrete. And the third is the average particle size of cockle shell was 13.56 mm. Okay, the more the surface area and reactivity of each reaction with other substance to form binder with appreciable strength. Okay, then methodology means proportion. Okay, next is methodology lab test. Flow table test is to determine the effect of water cement ratio on workability of mortar containing cockle shell. And compressive strength test is to determine the effect of water cement ratio on compressive strength of mortar containing cockle shell. And for the water adsorption is to determine the effect of water cement ratio on water adsorption of mortar containing cockle shell. Okay, this is the workflow, and go to result and discussion lab test. Okay, effect of cockle shell on workability. Okay, all flow achieved were within the prescribed limit specified by the ASTM C1437, ranging from 105 to 115%. The mix of 0.5 water cement ratio had the highest percentage of flow table, which is 111. The water cement ratio of 0.5 and 0.45 resulted percentage of flow table 75% and 106.7% respectively. All the flow table results fell under the acceptable range. So for effect of cockle shell on compressive strength, for 7 days, the mortar tube with the highest compressive strength are those with controlled water cement ratio of 0.6 and compressive strength of 28.96 megapascal. The mortar has compressive strength of 5.167 megapascal, 34.82 and 19.82 for 0.4, 0.45 and 0.5. For 28 days, the control mortar with 0.6 water cement ratio exhibit the strongest compressive strength of 36.12 megapascal. The compressive strength of 0.5 water cement ratio mortar is 31.481. Mortar with water cement ratio 0.4 and 0.5, compressive strength of 7.937 and 29.631. Only one mortar with mixed with 50% cockle shell obtained the specific strength of 30 megapascal after 28 days, as mentioned in Mishra report. Okay, effect of cockle shell on water adsorption. On 7 and 28 days, mortar kept with a controlled water cement ratio of 0.6 had practically constant water adsorption of 8.81% and 8.8%. The water cement ratio 0.5 had the lowest water adsorption, which was 8.3% and 7.83%. On 7 and 28 days, the mortar with a water cement ratio of 0.4 absorbed 13.25% and 12.93%. The mortar with a water cement ratio of 0.5 absorbed 9.93% and 8.08% of the water respectively. The relationship between compressive strength and water adsorption. Okay, the correlation coefficient of this equation was 0.7206 and 0.8817 for 7 and 28 days. Okay, for conclusion, the workability of mortar containing cockle shell improves as the water cement ratio increases. The greater water absorption of the water cement ratio directly affect the workability of mortar using cockle shell as partial cement replacement. The compressive strength of a mortar containing cockle shell as a partial cement replacement is highly influenced by the water cement ratio. The strength of mortar will be improved by partially replacing cement with cockle shell. The highest compressive strength is 31.481 megapascal in a mortar with a water cement ratio of 0.5 and 15% of cockle shell. Further decrease in the water cement ratio will lead to a decreasing compressive strength. The water adsorption value drop as the water cement ratio containing 50% of cockle shell was increased. Water adsorption show that the greater the water cement ratio with 15 cockle shell, the lesser the porosity and the lower the water adsorption of the mortar. After 7 days, water absorption of mortar with Cockle shell as a cement replacement is greater than 28 days. The correlation coefficient of this equation was 0.7206 and 0.8817 for 7 and 28 days, indicating that the degree was high. Okay, for recommendation, study on the effect of different curing method on the mechanical properties. Study on the effect of mortar on durability under acid and sulfate environment. And lastly, study on the effect of various percentage of supervises on the workability and mechanical properties of mortar. That's all from me. Thank you.